All right, we are on YouTube. So last week we left off kind of here. We're recording. I am 90% sure. Okay. So we did go over this, but just it's kind of a good platform to just talk about where we left off. So looking at this top portion right here, where it would normally take a lot of energy to have a reaction occur, and then if we do have an enzyme that's present, we're able to reduce the amount of energy needed for that reaction to happen. You can see how much energy you don't need if an enzyme is present. Why? Enzymes, they like to put things in the right position, right? And if there's enough energy to shove them together, so to speak, the reaction will occur. So enzymes are able to put the molecules in the correct position so that less energy is needed in time to align them, all right? So enzymes are really important. Remember, reactants in an enzymatic reaction are called substrates, and the products are still the products, okay? How about this? Is there one enzyme for every reaction, or can you use the same enzyme again and again? Is there one enzyme for every reaction in the human body? Or do some enzymes do more than one? I know we went over this. That's why I'm reviewing it. A lot of you say yes. Some of you say no. So I know there's 21 of you. Okay. So I know that enzymes will help chemical reactions, and yes, there is only one for every reaction out there. You cannot use the same enzyme for different chemical reactions. There's one for each specific chemical reaction. Okay? So each enzyme has an active site. We talked about this a little bit. I think we already took these notes, but we didn't. Okay. And this is the region where the reaction takes place. And I'm going to show you a picture of that in a minute. It's where the action happens, right? It's the active site. That's where it makes sense. So the shape of the active site determines where the reactants or substrates will actually bind to. So think of the active site as the keyhole, all right, and the substrate as the key. And it will bind to it. And each different enzyme acts only on specific substrates. So the question, is there a different enzyme for every chemical reaction? Yes, there is. So binding of a substrate causes the enzyme shape to change, and this change causes some bonds in the substrate to break and new bonds to form. Think of it as like putting a fortune cookie in your hand, and then your hand changes shape, and it does what? It breaks the cookie in two, right? And then the reaction occurs. I love Chinese food, and I didn't get to go to Chinese food yesterday. Oh, it's not right. My one day of the week, Sunday, I usually go get lunch at the Chinese place, China Inn in West Branch, and I didn't get to go yesterday because I was cutting trees in the woods, and it messed my whole weekend up. Me, General Tao's chicken. All right, so, and I get the hot and sour soup, General Tao's chicken with white rice. I don't like the crunchy that they give them to you. I usually give them to the kids. I don't like them. All right, so, folks, this is the enzyme. This is the substrate. This is my hand. This is the fortune cookie. This is the place where all the action happens, called the what? The active site. I put the fortune cookie in the active site. In my hand, my enzyme changes shape, and it breaks it into two products with a fortune inside, right? Okay. What? The enzyme changes shape. Buddy, that's a 2D picture. I can only get so, you know what I mean? All right, okay. You got to use your imagination. Just pretend you're Mr. Rogers. You go to Imagination Land for a minute, and we just imagine. Now I got the John Lennon song in my head. Imagine all the people. Yeah. My daughter's singing that for a talent show that's coming up, so it's in my head. All right, so enzymes. Many enzymes are proteins. Oh, how do you get a protein? You copy DNA onto RNA. RNA wiggles through a nuclear pore, goes out into to find to make by assembling. All right, good deal. You were all officially brainwashed. All right. So changes in temperature and pH can change a protein shape. Hey, are eggs high in protein? What happens if you heat an egg up? Bubbles, boils, solidifies. Let me ask. I went back to old school. What happens when you heat an egg up? Sorry, I didn't mean to do that. I just remember how chaotic class used to be before I had Pear Deck. A lot of talking back and forth. Only one or two people would answer most of the time, though. That's a problem, right? You know what I mean? Like, when have you ever seen 21 kids answer the same question every time? Doesn't normally happen. So, like, the way I used to teach was great for, like, 4 kids, but this is a little better, right? Yeah. So I can wait, and everybody has to answer. That way, it's called think time. If I showed the answers and it was up there, people would either type it in or they would not even try, you know. Come on, let's get over 20. I know there's 21 of you. Now I don't remember. What was the question? What happens when you heat an enzyme up? Yep. Come on in 5, 4, 3, 2, 1. Let's see what happens. It becomes a solid. Okay, kind of. Yep. It cooks. It cooks. Yes. No, cooks. DNA. Oop. Tasty good. What's this one? You get a sunny side up egg with butter American homemade sausage. It's like that's a Denny's Grand Slam right there, I think. Creates a tasty good, solidifies. All right, fills the pan, scrambles omelets. Over easy. Bacteria are killed and solidifies, cooks, change form, hard boil, hardens, becomes acceptable. There's a little chance you get salmonella. True. Now let's talk about why we cook things, period. Here. So, don't worry about it. So, proteins make everything up, right? Our viruses and bacteria are made of proteins. Yeah. And if you sterilize things, you can do that by boiling them, right? Cooking them. Okay? You're denaturing. Everybody say denature. Denature. So you change the shape of the protein. If you change the shape of the protein, you change the shape of what? The active site, right? Will the reaction occur anymore if you change the shape of the active site? Everybody say no. No. So by cooking the egg or the protein, you denature the protein. I know. I just remembered. So you can change the shapes of proteins a few different ways. Temperature is one. Another one is pH, like making it real acidic or real basic. Most enzymes function really well at certain pHs. The ones in our stomach, they like an acidic environment. The ones in our blood, they like a slightly basic one. Depends on where you're at. But, folks, just understanding that an enzyme is a protein, and we cook proteins all the time, and we kill proteins that are in bacteria so that they don't hurt us, and viruses so that they don't hurt us. It's called sterilization. That whole idea is why when you change the proteins, the enzyme shape, it doesn't work anymore. Okay? So, you guys have a substance in your liver that breaks hydrogen peroxide down into oxygen and water. Pretty important enzyme, right? If your core body temperature gets above like 105 for any amount of time, you literally scramble your liver and you cook those proteins. So what happens to you? You die of hydrogen peroxide poisoning, literally. That happened to a young man who was wrestling at U of M about, oh gosh, I'm old, 15 years ago. Okay? He did. He was cutting weight, he slept in his plastics, and his core body temperature got above 105 for like 5 hours or something crazy like that. He walked in to weigh in, he weighed in, he was dead when he hit the scale. He made weight, went in the locker room and collapsed, and he was dead about 2 hours later. So that is an extreme example of an enzyme getting cooked, literally. They don't work once they're cooked. So looking at your metabolism, this has a lot to do with how you break down your food. Cells get most of the energy needed for metabolism by breaking down food molecules. And the release of energy from food molecules occurs in a series of reactions using many enzymes to capture energy in the form of ATP molecules. We talked about that before. And the enzymes reduce the activation energy so much that only a little energy is needed to start the reactions. And in this process, very little energy is lost as heat. Enzymes have the ability to efficiently use energy by using the least amount possible to make that reaction occur. So we've talked about quite a few things. Living things use different chemical reactions to get the energy needed for life processes. There is such thing as an activation energy that's needed to start chemical reactions, and the reactants must also be aligned to make the product. So alignment and enough energy for a reaction to occur need to happen. There are special biochemical reactions that use enzyme to reduce that amount of energy to maintain homeostasis, okay? They hold things in correct alignment and reduce the amount of activation energy needed for the reaction to occur, thus making you more efficient and prevent energy loss. Yes?